All right, first thing. Naming a matrix now. All right, naming a matrix. You could see it as a capital letter, A, B, C, capital letters, or with a lowercase letter. And I'll talk about what the lowercase letter means in a second. Square matrix, equal number of rows, equal number of columns. So we called them three baggers, 3 by 3. That's called the square matrix because it's got the same amount of rows as the same amount of columns. Now when we go to find the order of any matrix, order, here's what I'm looking for the order. You're basically telling me how large it is. How many rows and how many columns. It's got to go rows by columns, all right? Rows by columns. So rows by number of columns. The only thing I worry about is making sure you get the rows first. So in this one, how many rows do I have? 2. And how many columns? 3. So the order of this matrix is 2 by 3. Okay, number of rows times the number of columns. All right, I told you could see a capital letter. Well, you could also see a lowercase letter. And with the lowercase letter, there should be 2 little subscripts next to it. So you see here it says A, 2, 3. Remember the order it goes. Row, column. So I need to know the number, what's put into row 2, column 3. So take a look at this matrix. Row 2, column 3. What do you have for me? -1/5. So this is equal to the entry -1/5. Everyone see where I'm getting that from? Row, column. Row, column. And then if you're on your game, what about 1, 2 now? Well, I'm hearing different answers now. Row 1, column 2. Row 1, column 2, boom, I'm at 2. And I'm going to add another one in here. Is everyone all right with that? What's your problem? Okay. Not possible. I may throw a not possible at you. So this is not possible. Okay. Because there is no row 3. Hey, everyone doing all right? Okay, let's keep this fun drill going here. Any big weekend plans going? Okay. Wow, flower garden show. It's just a bunch of flowers. Koi ponds. How does that place smell? Is it just overwhelming or? It's got flowers there, Hannah. Gotcha. Okay. You are. Enjoy yourself. Blowing her up or taking her out? Never mind. Sorry, Matt. Too wrong. Too much? Sorry. I went over the line there. I went over the line. Sorry. I went over the line. Yep. Yep. What is that? Going to the department store, picking up the mannequin. Right? Right. All right, moving on. Moving on. Have fun tonight. All right, have fun. All right, behave. Have fun. Okay. Never mind. So wrong. You just took it like 20 steps over the line. All right, let's go. Let's go. Let's go. Equal matrices. Two matrices are equal. They have the same order, same rows and same columns, and what's inside are the same. So can you give me in this example here on number 2, what values of x, y, and z would make those two matrices equal to each other? So again, right here, I need a 4. So guess what the value of x is going to be? 4. What about the value of y, though? Y 6. I needed a 12, and it's 2y. So that would be, yep, y would be equal to 6. And then how about your z value? 3. Okay, not too bad. Okay, not too bad. All right, you ready to add and subtract now? Okay, we can only add and subtract if two matrices have the same order. So they both have to be 3 by 3. They both have to be 2 by 3. Okay, and it's very easy to add and subtract. All you do is add and subtract the corresponding, what did I call them here? Positions. So row 1, column 1's got to be added to row 1, column 1 in the other matrix. All right, so when I add these two together here, I'll go slow even though I know some of you are already flying by me. 0 I can only add with what in the other matrix? What's in row 1, column 1 in the other one? -2. So what's my new, when I add those two entries together, it'll be -2. 5 plus 3, 8. 3 plus 5, another 8. I'm good. And then what about row 2 here? -2 plus 7, 5. Why am I hearing calculators? 6 plus -9, -3. -8 plus 6, -2. All right, no big deal. Subtraction, just worry about subtracting a negative number. Then it becomes positive. Okay, so for this one here, can I get a little help here? -6 minus a -5. -1. Are we okay there? Because it becomes plus 5. -6 minus 6. Oh boy. Where am I missing people?
I missed the signs up.
Wait, you guys. No, never mind. I'm sorry. Calm down. Don't start. Don't start. 7 minus 6. Laugh it up. Yep. Ha ha ha. Right. 2 minus 0 here. 2. -3 minus 4. Positive 1. Go ahead, Hannah. What do you got? Doesn't that become plus 4 though? You good? Okay. Even the great ones make mistakes, right? Okay, even the great ones. Yep. All right, you're done. You're done. All right, you're done. Okay. I can also multiply a matrix by a number. Pretty easy. Did you just say scholar? Is there an O in there? A silent O I don't know about? A scalar? Okay, multiply by a scalar of 4. So now, and I show that now by matrix A being multiplied by 4. And I just multiply all the entries by 4 now. So 2 times 4, 5 times 4. So we're ending up with 8, 20, -12, and 0 stays 0. All right, let's try to combine all this now. Here's matrix A, matrix B. Can you find what -5b would be equal to? So I'm going to take B and multiply all its entries by -5. New matrix would be -10, 15, -25, and 30. Okay, here's where I have to slow it down now because not only am I going to multiply, I'm going to add 2 together now. Part B, 2A plus 3B. So the first thing I need to do is multiply matrix A by 2, matrix B by 3, and then I'll add them together. So here's how I'm going to show this. I'm not going to do it all at once. I can't do all that in my head, no way. Okay, so let's first do 2A together. So what's my new matrix after 2 times matrix A? That's what I was thinking. -2, 8, 6, 0. There's 2A, everyone. Now let's go 3B. 3B, 6, -9, 15, and -18. Now let's add them together. Four, -1, 21, -18. Any issues putting them together? Okay. Wow, it's not even that long today, huh? Solving a matrix equation now. Solve for x. So basically, here's what I'm looking for. I need a matrix that I can multiply by 2, add it to matrix A, and I'll be left over with matrix B. That sounds like a mouthful, but it's not, because I'm going to make this easy on you. Don't even touch the matrix. Don't even touch each matrix. Take this equation and solve it for x first before you touch any of the matrices. So help me out here. 2x plus a equals b. Solve it for x first. What do you got for me? Move what over first? Move the a over. So 2x equals b minus a. And then what do I need to do on both sides still? Divide by 2. So x equals, now I'm going to make this easy. Because both of these are being divided by 2, I'm going to have you guys rewrite this as 1/2 b minus a. Everyone agree that that's the same here? When you distribute, you get b over 2, and you get a over 2. Now what I'm going to do is b minus a. I'm going to take b minus a, and then I'm going to multiply it by that scalar of 1/2. So solve it for x before you touch any of the matrices. So here we go. Let's do b minus a right now. B minus a. Can you give me the new matrix now? Oh, boy. B minus a. B minus a. -7. I'm waiting. Keep going. 5 minus a -5. 10. 9 minus 0. 1 minus 2. Okay, there's b minus a. And now I'm going to take that and multiply it by a scalar of 1/2. So what is my matrix X that will solve this equation? -3.5, 5, 4.5, and -0.5. Okay, so that is matrix X that I would be looking for there, the value of X. Anything you want to ask there? We got one more, it looks like. Not bad. Just a quick review. What would be the order of A? The order of A. What type of matrix is this? How many rows? 3 by 2. That would be a 3 by 2. Yep, good. All right, so here we go. 4A plus 3b equals negative 2x. Solve it for x first before you touch the matrices. What do you want me to do on both sides? Divide by negative 2. So x equals, how can I rewrite this? So some of you guys are trying to divide here, right? And then what are you doing here? Okay, I'm going to do, just so I'm consistent with what I did above, I'm just going to leave this as negative 1/2 4a plus 3b. If you guys want to try to go and do negative 2a minus 1.5b, go right ahead. That's up to you. Okay, I'm going to be consistent, though, with what I just did. All right, first step. What do you want to try to find first? There's a lot we got to do here. Looks like we're going to multiply, add, and then multiply again. So what do you want to do? 4a first? Okay, let's do 4a. So 4a will be, and do you have to put the little 4a above? No, I'm just showing everyone, hey, I'm doing 4 times matrix A. Negative 12, negative 28. What else we have? 8, negative 36, 20, and 0. We're adding that to 3b. Negative 15, negative 33, 0, 0, 9, and oh, here we. Oh, that's a look. Never mind. I'm not going to make excuses, but that looked like an 11 at first glance. Sorry. I really don't like any of you. I really don't. Somehow I got to get through 3 months. Okay, add them up. All right. Okay, you're not a thug now. You walk around like you're a big thug because you went to restricted for a ridiculous. Yeah, they do. Yeah. Yeah. Did you get shanked in there, or does anybody jack you up in there? Okay, here we go. Come on, let's just finish this up here. Negative 12 plus negative 15, negative 27. Negative 28 and negative 3. Negative 31. 8 and 0. Negative 36 and 0. 20 and 9. And 0 and negative 12. All right, and what do I still need to do to this one? I still have to multiply it by 1/2. Negative 1/2, yep. Okay, let's finish this now. Multiply it by negative 1/2, so that'll give me negative positive 15.5, 13.5. Now it'll give me 15.5, negative 4, positive 18, negative 14.5, and then finally positive 6. So there's my final matrix that will solve that equation. And then you guys have the classwork on Monday. Look at that. It was. Hopefully we don't forget most of it.